So when you're adding and subtracting radicals, just remembering that what's behind the coefficient has to be alike. So you have to, for radicals, that would mean the exact same root with the exact same value underneath of it. When we've got variables thrown in, it still just means like, hey, whatever is behind that coefficient. So like we've got a coefficient of 10 and 1 currently should be alike. So like we have right now the square root of 5s to the 7th and then s square root 80s fifth. Like they are nothing alike. So we need to just simplify both of these. And then hopefully when we're done, they should be exactly alike. Like terms, we can subtract them. So we're just going to focus on this guy first. Like don't even pretend the other one's not even there at the moment. So 10 times the square root of 5s to the 7th. We can't do anything with the square root of 5. So that's just going to stay square root of 5. But we can do something with s to the 7th. So like remember when you don't see a root, it's a square root. So we would write this like as s to the 7 halves. So how many times does 2 go into 7? 3 times. So you can also write it out in an expanded form, remember? So like if you wanted to write it out as 1, 2, 3, 4, 5, 6, 7, how many groups of 2 with how many left? 1. So this guy is done. So this ends up being 10s to the 3rd times the square root of 5s. Like that's our expression simplified. So now if we go take a look at the second one, can we take the square root of 80? Are there any perfect squares that 80 is divisible by? Yes, 16 times 5. So we've got the square root of 16, that equals the value for, I'm going to just bring down my minus sign. So we still have 5 left underneath there. Now let's look at s to the 5th. So we could rewrite that as 5 halves. You could write it as 5 s's. How many groups of 2 with how many left? But 2 goes in to 5 twice. So like we would bring s squared out, but because there's already an s out there, that 1 with the 2 that we're bringing out is going to make s to the 3rd. And that checks out because our first expression had s to the 3rd in it, with 1 left. So now, this part that's behind our coefficient is exactly the same. So if you're confident that you did this first expression correct, it's a good check that your second expression ended up exactly the same. So it's a little weird to sort of say, but we're saying how many s to the 3rd times square root 5s's do we have? So we just keep that part that's alike. We keep this s cubed square root 5s, subtract the coefficients. 10 minus 4. So like I said, it's a little messy, it's a little weird, but just simplify both radicals, both expressions. They should end up being alike, and then you add or subtract just the coefficients. The part that's behind them that is the same stays as it is. So kind of similar, if we rewrite number 14, I'm just going to rewrite these variables that have fraction exponents in root form. So I'm going to rewrite this as 15 a to the 4th cubed root b squared plus 8 a to the 4th cubed root b squared. So that part that's behind your coefficient, behind the 15 and behind the a, is exactly the same. A 4th cubed root b squared. A 4th cubed root b squared. So you're just saying, how many of them do you have? So 15 plus 8, 23, keep the like part. So for adding and subtracting, you really should get them to be the same and then just add or subtract the coefficients. But you've got to simplify them first.